Good afternoon, I'm Andre Stander. I work at Stewarts Lloyds Robertville. I'm the sales manager here, and I'm here to discuss the project we recently finished with Nike, as well as Billet Construction and Estee Automation. So what we did was we built and formed a roofing section out of wire bar. It was 498 frames built into a complete 400-ton steel structure that was put up at Nike Soweto. So what we did was we took Y8s and we bent them to a degree that was not possible, and it formed a frame that has got 3 different Nike signs built into it. If you stand underneath it, you will see the different Nike signs from different angles, and we basically took 28 sections of Y8s built into 6 pieces, broken down to about 176 tons just of the wire bar alone, built into different frames. And these 498 frames were put up into the air as per the instructions given by Billet as well as Estee. And we basically made a world's first by formulating different sections, different structures, and making wire bar actually becoming something that looks like Nike, and Nike being the first company that actually introduces it like this. So what we did was we took all of these little sections, bent them and fixed them together from different degrees, different angles, to formulate sharp point sections, making them frames that's called Rebar slats. That Nike now has got the first and the world's first literally structure built, whereby you have a whole section of rebar going up into the air. So what we did as a branch is we got involved with bending yards, asked them to assist us to bend and make frames for Nike itself. So what we could do is we could only build and bend a rebar up to a certain degree, and we had to literally forge pins, and we had to forge the whole section out of special steel so that we can actually bend the wire bar, because all the pins were breaking due to the fact that we were bending it at such a high degree.
Hi everyone, I'm Praveen, part of Inspire Consulting. We were the lead civil and structural engineers on the project. When we looked at the project from the start, we first looked at materiality and started discussing how is it that we're going to put this whole frame together and create a canopy that not only speaks to Nike's quality, but also to the innovation aspect of the project. We started off by looking at all sorts of systems, and we decided, or at least with the team together, we decided that Rebar is going to be something which is quite out of the box. And I think that personally, we are so used to detailing rebar and having it being hidden in concrete that it was a really good breath of fresh air to see our rebar out in the open for everyone to enjoy.
And I'm Odette with Aspire Consulting as well, assisting Billet on the actual design of the canopy. I think we never realize what actually goes behind the scenes in terms of getting an angle bent or getting something put up into the air. And once it all starts getting pieced together, it's like all the pieces of the puzzle fall into place. For us, I mean, like Billet mentioned, the cantilevers were massive. The rebar is obviously heavier than a lot of other elements we deal with. And it's hanging in the air, which means it's subjected to all sorts of wind movements and, the connections and how those things all fit together needed to be carefully designed. We had hesitations in the beginning in terms of using reinforcement, because obviously South African temperatures are such that we get really hot summers and really cold winters, and we were a bit concerned about that thermal differential. And also we were also a bit concerned about how something as rebar is going to provide shade to big, large open areas. But once it was all completed and it all came together, walking underneath the rebar, we had created patterns on the actual fields, gives you almost like a psychedelic feel.
Hi, I'm Yuri from Estee Automation, and we do the steelwork, the manufacturing portion.
My name is Carl Jacobs. I'm from C76. We were architects, so we were the architects on the Shapa Soweto project. So I'm just going to give you a short explanation on the design of the project, and I think then Yuri will take over from there. So basically, it's in Soweto. There was existing building that we had to connect to Chris Hornet Drive, and we had to shade the area, and basically it boiled down to what can we do which will shade, will still be practical in terms of shading first of all, and we ended up doing these 4 meters, I think, by 2 meters rebar tiles, which was like 3D shaped for practical reasons. We just did some research on double the layers, shaded more than a single layer. We debated what material, and I fought for rebar and all that type of stuff, and at the end of the day, it ended up being the only choice.
So these tiles that Kyla are talking about, so there's 410 of these tiles, identical. Now each tile has 168 rebar triangles in it, and the difficulty of this is that each of these rebar triangles are different in size, but only by 2 millimeters. So you've got 168 triangles, and then each one is 2 millimeters smaller than the next one on all three of the corners, and that then gives you the shape of a three-dimensional triangle. Now, the problem with that was, first of all, the quantity of the material. It was at the end of the first lockdown, so material was very scarce, and we were going to need about 90 tons of this. Second problem that we had was to actually bend these things accurately enough, and in the beginning the idea was to build it in one triangle, but we then later changed it to 2 triangles cut in half, which was oversized, and we then cut it 2 size in the workshop. So Andre helped us with procuring the material and to do the first bend, and we then took it over from there, fine-tuned the bend, cut it to size, put it in jigs, and welded it up.